Hello everyone, I am Harsha H N, studying in Manasa Gangotri, Mysore. My topic is SVM classifier, linear separable, non-linearly separable cases, kernel functions, presented by Group 2 Harsha H N. So before we start with SVM, understand the application. Where can use handwriting, character text, categories, high dimensional data. This can be used SVM classifier. Let's see the definition. What is SVM classifier? Support vector machine. SVM is a supervised machine learning algorithm which can be used for both classification or regression challenges. However, it is mostly used to classification problems. The SVM classifier is a frontier which is the best segregates the two cases, hyperplane and line. Once again I am saying the SVM classifier is a frontier which the best segregate the two classes, hyperplane and line. Let us see support vector machine algorithm. Support vector machine or SVM is the one of the most popular supervised learning algorithm which is used for classification as well as regression problem. However, primarily it is used for classification problem in a machine learning. The goal of SVM algorithm is to create the best line or decision boundary that can segregate the n-dimensional space classes so that we can easily put the new data point correct category in the future. The best decision boundary is called hyperplane. SVM chooses the extreme point or vector that helps creating the hyperplane. These extreme cases are called as support vector and hence algorithm is termed as a support vector machine. Consider the below diagram which is there are two different categories are the classified using decision boundary or hyperplane. See this image, maximum margin and positive hyperplane and two colors are there. One is blue and another is green and is that support vector and negative hyperplane and maximum margin hyperplane is that image. Let us see example. SVM can be used to understood the example that we have used the KNN classifier. Suppose we see strange cat that also has some features of dog. Suppose we see the strange cat that also has been some features of dog. So if you want a model that can accurately definitely identify whether it is a cat or dog. So such a model can be created by using the SVM algorithm. We will first train our model with lots of images of cats and dogs so that it can learn about different features of cats and dogs, and then we test with its a strange creature. So as a support vector creates a decision boundary between these two data, cat and dog, and choose extreme cases support vector. It is will see the extreme cases cat and dog on the basis of support vector. It will classify a cat. Consider the below diagram. This is the diagram. One is data is cat and another is dog. Past labeled data and move on to the model training and prediction, or what is it is a cat or dog, and output is cat. It is a cat. Types of SVM. Linear SVM, another is non-linear SVM. Let us see linear SVM. Linear SVM is used for a linearly separable data. Linear SVM is used for linearly separable data, which means if a data set can be classified into two classes by using a single straight line, then such data is termed as a linearly separable data, and classifier is used called as a linear SVM classifier. Non-linear SVM. Non-linear SVM is used to non-linearly separable data, which is means if data set cannot be classified by using a straight line, then such data is termed as a non-linear data, and classifier called as non-linear SVM classifier. Linear SVM. The working of SVM algorithm can be understood by using a diagram. Suppose we have a data set that has two tags, green and blue, and the data set have two features x1 and x2. We want a classifier that can classify the pair x1, x2 the of coordinates in either green or blue. Consider the below diagram. Is that diagram? Continue the linear SVM. So it is this 2D space. So by just using straight line, we can easily separate these two classes. But there can be multiple lines that can separate these classes. Consider the below images. And finally, hence the SVM algorithm helps to find the best linear line or decision boundary. This is the best boundary or region is called as a hyperplane. SVM algorithm finds the closest point of the lines from both the classes. These points are called support vector. The distance between the vector and hyperplane is called as a margin. And the goal of SVM is to maximize this margin. The hyperplane maximum is margin is called as optimal hyperplane. Let's see non-linear SVM. Non-linear SVM is the data linearly arranged. Then we can separate it using straight line. But for the non-linear data, we cannot draw a single straight line. Consider the below images. This is the images. Non-linear SVM. So now SVM will divide the data sets into classes in the following way. Consider the below images. So to separate these data points, we need to add one more dimensional. For linear data, we have to use two dimensional x and y. So non-linear data, we will add a third dimensional z. It can be calculated as z equal to x2 plus y2. By adding the third dimensional, sample space will become a below images. Non-linear SVM. Since our 3D space, hence it is looking like a plane parallel to x-axis. We converted 2D space with z equal to 1. Then it is become as so the see this image best hyperplane. Hence we can circumference radius 1 cases of the nonlinear data. Kernel functions. Kernel functions introduction is not necessary. I go to another slide. How does it work? To better understand how kernel works, let us use James mathematics illustration. Mathematical definition: k of x comma y x comma f of x comma f of y. Here k is the kernel function. X y are n dimensional inputs. F is a map from n dimensional. So m dimensional space x comma y denotes the dot products. Usually m is much larger than n. Normally, calculating f of x comma f of y requires us to calculate f of x, f of y first and then do the dot product. These two computation steps can be quite expensive as they involves manipulation m dimensional space where m can be a large number, but after the trouble going to the high dimensional space, the result, the dot product really scalar. We come back to one dimensional space again. Now the question we have, do really need to through all trouble get this one of the number of do really have m dimensional space? Answer: no. If you know clever kernel. Simple example: x is equal to x1 comma x2 comma x3, y is equal to y1 comma y2 comma y3. Then the function f of x, x1 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 x2 etc. Then kernel f of k of x comma y whole square. Let's plug some numbers, make more intuitive. Suppose x is equal to 1 2 3, y is equal to 4 5 6. F of x 1 2 3 2 4 6 3 6 9. F of y 16 20 24 20 25 30 24 30 36. F of x comma f of y total result is 1024 at lot algebra, mainly because mapping three-dimensional space. And next slide is Now let us use the kernel instead. K of x comma 4 10 18 power of 2, it's 32 square 1020, same result. It's the machine learning expert. Let us see types of kernel functions. Linear kernel documentation, linear kernel source code, how creates the svm in net with accord net. The linear kernel is the simplest kernel function. It is given by the inner product x comma y plus and optional constant c. Kernel algorithm using the linear kernel are often equivalent of the non-kernel counterpart, and that is kpca with the linear kernel is the same as standard pca. K of x comma y equal to k x power of p y plus c. Polynomial kernel is a non-stationary kernel. Polynomial kernel are well suited problems where training data normalized k of x comma y alpha x power of t y plus c power of d. Adjustable parameters are the slope alpha and constant term c and the polynomial degree d. And gaseous kernel. Gaseous kernel is an example of radial basis function kernel. K of x comma y expect left fraction and what and x minus y are what x power of 2 2 sigma power of 2 right. Alternatively, it could be also implemented using k of x comma y x fifth and gamma what x comma y are power of what and power of 2. Thank you so much.